Hello, welcome to this channel. My name is Enoch. Today we'll be looking at infrastructure as code. We will try to define infrastructure as code. We will look at its benefits, its approaches, and we will do a demo where we will be creating a web server, the network, and security component on AWS using infrastructure as code. And what is infrastructure as code? Infrastructure as code means defining your infrastructure with a code file. Defining your servers, your networks, and other infrastructure components in code files. These files are stored or may be stored in a version control system like Git, allowing you to track changes over time and automate provisioning. So what are some of the benefits of infrastructure as code? One, it enhances a speedy deployment of infrastructure. You can deploy full environment in minutes, not hours. And with one simple command, you can spin up your network, your server, and storage. And this is ideal for rapid testing, recovery, and innovation. You also get consistency and repeatability with infrastructure as code. No more snowflake servers. Every environment is identical, reducing bugs and ensuring reliable scaling. With the ability to also store your code in a version control platform like GitHub, you're able to track infrastructure changes, roll back easily, view change history, and improve auditability and compliance. With infrastructure as code, collaboration become easy. Team can review infrastructure changes just like application code, catch easily, enforce standards, and share knowledge. And infrastructure as code also helps in cost control. You can easily, with a simple command, destroy your infrastructure, reducing the chances of racking up cost due to forgotten infrastructure. And what are some of the approaches to infrastructure as code? The first one is declarative approach. This is a situation where you define what the final infrastructure should look like, and the tools figure out how to get there. An example of such tools are Terraform, AWS CloudFormation, Kubernetes, YAML Manifest. And some of the pros of this approach is it automatically handles dependencies, it detects and corrects drift, and it's easier to manage at scale. And some of the challenges or some of the cons in this approach is that it gives you less control over the step-by-step process, and debugging can be harder in complex scenarios. And this approach is ideal for managing cloud resources where the end state matters more than how it is reached. And let's do our first demo, which will be on Terraform. And I'll be going to my shell now for us to start the demo. All right, this is my Terraform file, and I've defined it. I have variable.tf, I have the main.tf, and let me just explain what the code does. This variable.tf file contains some of the variables I want to use. This is the VPC CIDR. I'll be using this particular CIDR, and this is defining the CIDR for the public subnet that I want to create, and this is defining the AWS region that I want to use. All right, and that's that. And this is main.tf, and this is a provider block, which gives us an opportunity to define the provider that we want to use. Terraform is a cloud agnostic tool that is used to create infrastructure on multiple cloud infrastructure provider, and anytime you want to use Terraform, you have to state the provider that you are using. And this one, I'm using AWS, and I'm using it to define the region that I'm using, telling the system to check the variable file for the region I want to use. All right, and this is a resource block that is used to create the VPC, which is the network that I want to use. This is stating the CIDRs that I want to use, referring to the variable file again to get the CIDR. And this is a resource block creating subnet and attaching it to a VPC. And this is a resource block creating the internet gateway, attaching it to a VPC. And this is a resource block creating route table, attaching it to a VPC, and stating the gateway ID. And this is a route table association resource block. It's used to associate the route table to the public subnet. And this is a resource block that is used to create the security group. And we give the name, description, VPC ID, and we define incoming traffic rule. For this, we allow port 80 from anywhere. We allow port 22 from anywhere. All right, and this is outbound traffic egress. This outbound traffic, allowing outbound traffic, to anywhere. So that's that. We also have a data lookup block here, which is used to import an AWS AMI that will be used to create the EC2 instance. It's an Amazon Linux machine that will be used, and this is the web server block that is used to create the web server, which is the EC2 instance. We define the AMI, which is referring to the data block that is created above. This is the instance type, the subnet ID, the VPC ID, and we're allowing to give a public IP address, and we'll tag it, and that's it. These are code. We only need to run a simple command and our infrastructure will come up. So for the sake of time, I have already given the authentication that is needed. All I have to do is to run a simple command to bring up our infrastructure. So Terraform apply. Let me make sure that it doesn't ask me any question. So Terraform apply, and there we go. It will start creating our infrastructure right away. To tell us first what it's going to create. It's going to create nine resources, 0 to change, 0 to destroy. And if you check up, you can see what it's going to create. Is going to create an EC2 instance. Is going to create a route table, a public route table. It's going to do a public route table association. It's going to create security group, and is going to create a public subnet. Is going to create multiple public subnet. Of course, it's going to create a VPC, and that's that. And you can see here it has started create the VPC. Then it went ahead and created the internet gateway. Then the subnet, the route table association, subnet. So now the creation is completed. Let's go to the AWS Management Console to go and check what has been created. Now, this is the resource that has been created. This is the EC2 instance. And if you check the tag, is the same tag that we give it, ISC demo web instance. If you check our main.tf, you will see the tag. That's the tag there. So that's to tell you that this is from the Terraform code that has been created. If you check the network, you will see the VPC that we created. You can see the VPC, you can see the subnet, you can see the VPC, you can see the tag from the VPC. That's exactly what we gave it. So that's that. So with a simple command again, I can go ahead and destroy my web server. Terraform destroy. This time around, I will let it ask me for approval before destroying the resources. All right, now it's asking me for approval. I will just give a simple yes, and it will go ahead and destroy the infrastructure. All right, the infrastructure has been totally destroyed. You can see all the infrastructure created with this code was totally destroyed. I don't have to go into the management console and go and delete one after the other. It makes work very easy. It's know the order to destroy it. If you look at it, start the destruction from the route table association. It went down to AWS to the instance. It went down to internet gateway. It destroyed them in order. You don't have to worry about it. So if you go to the console and you check this out, you will see that the infrastructure has been destroyed. True. And that's it. You can see that it's gone. It's no more there. So if you come and check the VPC, everything is gone. So I don't have to worry about going to destroy them one after the other. It has destroyed everything: the VPC, the subnet, the internet gateway, the server, which is the EC2 instance. That destroy everything. That's the good thing about infrastructure as code. You can see the code is repeatable, the code is reusable. I can, with a simple command, I can bring up all the machine again, the network, the security aspect of it, and everything will be up immediately. So it's reusable, repeatable, version control. I can commit this code, to GitHub, and anybody can access it, or fork it, or use it for whatever they want. So that's that. By the way, you can check GitHub. I'm going to put the link for this particular code on GitHub, and so that you can try it out yourself if you want. So let's see the second approach, which is the imperative approach. And this approach, you define how to create your infrastructure step by step, like writing a script. This particular approach is useful specifically for developers who don't want to learn YAML or learn JSON, and with programming language, Python, TypeScript, Java or whatever, you can easily write your code and deploy it on your cloud infrastructure provider. So that's it. But this is not as simple as the declarative approach. This one is imperative. You define step by step how to create your infrastructure, just like writing a script. So example of such tools include AWS CDK, your Ansible, which is a configuration management tools, your Chef, your Pulumi. And some of the pros for this approach is that it gives you a fine-grained control over execution. It's easier to understand for those with scripting or programming background. And some of the cons in this is that you must manage dependencies manually, has higher chance of configuration shift. And this approach is ideal for configuration management, provisioning VMs, or when the order of operation is critical. So let's go and do a demo on this approach in a CDK. All right, so this is our CDK code that we are going to use to deploy on AWS. By the way, CDK stands for Cloud Development Kit. It was created by AWS, and this is the code. So this is the core stack that we're importing the stack, the CFN output, and the AWS EC2. We're also importing the construct, which is a unit of deployment. So we define the class. It uses this is a Python. We are using Python programming language. So we define the class. It uses object-oriented programming. So we define the class, and we start defining the resources. We're defining the network, which is the VPC. We define the security group. We define port 80, allow from anywhere, and port 22 allow from anywhere. Then we create this is a resource block for the EC2 instance. Attach the VPC, the instance type, the machine image, the security group, and the output. We define the output. This will output the VPC ID. This will output the public subnet ID. So that's the code we are going to use. And this is CDK for you using Python code. I have given all the authentication that is needed, and with a simple command, we are going to bring up our infrastructure. All right, so CDK deploy, and this will bring up our infrastructure on AWS. All right, I'm going to give you the authorization to go ahead and create it. All right, you can see it's creating the VPC, the internet gateway, so like that is going to create all the resources one after the other. You can see the VPC gateway, has been created, completed. The subnet has been completed. The subnet route table association has been done. It has created the route table and the security group. It's creating the role that we need, All right, so our infrastructure has been created on AWS. Now we're going to go to AWS Management Console, and we are going to check what the infrastructure that we have created. Let's check this place. This is the EC2 console. This is EC2, and you can see that the CDK sample project has been created for us. You can see that's it. And see, this is it. And if you check your networking, you will see everything that we created. You can see the VPC. You can see the subnet that was created. Everything is from the CDK, and you know, CDK is an abstraction of AWS CloudFormation. So if you go and check CloudFormation, you will see this particular stack in CloudFormation. This is the CDK sample project stack. You can see it just created now, and that's it. I can go into it, and I can even check the event of things that it was created, you know, one after the other. So that's that. And with a simple command, I can simply destroy the infrastructure. Run CDK destroy and give your authorization for the destruction, and it will be done. All right, all our infrastructure has been destroyed. Let's go and check AWS and see. If you refresh, you will see that the stack has been destroyed. You can see the stack has been destroyed. This is just the CDK toolkit that we used during Bootstrap. If you check this server, you will see that this server is gone. It's no more there. You can see it's gone. So that's that for you for CDK. The imperative approach. Declarative is more popular for cloud infrastructure as code because it's scalable and resilient. You know, it handles drift and dependencies for you. But the imperative approach gives you more control, which is useful for procedural tasks or inside configuration tools. You know, so that's that for today. All right, before we go, I've discussed about the popular tools that is used for creating infrastructure. This is for Azure, this Azure Resource Manager, and for Google Cloud, you have your Google Cloud Deployment Manager. You know, so that's that. And so today we have looked at infrastructure as code. We have looked at some of the benefit of infrastructure as code. It's reusable, you know, it's repeatable. You can version your code and put it on a code repository like GitHub, you know. And we have looked at some of the approaches. We have looked at the declarative approach and the imperative approach, and we also look at some popular infrastructure as code tools. And in subsequent videos, I will be going into AWS CloudFormation, you know, in details, and we will do some projects, and we will create some infrastructure, and we will also look at projects where we will use our infrastructure in a CI/CD pipeline. And we will also go to CDK. We will do CDK, and we'll use CDK to create some serious infrastructure, and we will also use it to deploy a CI/CD pipeline. We'll go to Terraform, and we will do some Terraform projects too. So I hope you join me in that video. Thank you for watching, and see you in the next video.